G'day Methods students. In this video we're going to go through the quotient rule, which is another rule that we use to differentiate functions. This time, as you might guess from the name, we're using this to differentiate functions where we have a function of x divided by another function of x, and hence we call it the quotient rule. Now, of the chain, the product, and the quotient rule is probably the hardest one to memorize, so it's often a good one to come back to the formula, and they do put the quotient rule on the formula sheet for you, which is nice in exams. But essentially the rule is, if we have, and you can kind of refer to either of these, they're just the same rule with slightly different notation. If our original function y is written as u over v, okay, so that's important, u is the function on top and v is the one on the bottom, the denominator, then dy dx will equal v times du dx minus u times dv dx, all divided by v squared, remembering that v is u is the numerator and v is the denominator throughout all that. Now, even when you've got the formula in front of you, it's a bit of a tricky one to keep track of, so I'm going to show you a way that I like to set it out to try to avoid making some mistakes. So let's get stuck into an example. With example 24, we're being asked to differentiate 2x plus 1 over 2x cubed plus 2x. Now, to start with, we know that the u in the rule is the numerator, right? So in this question, u is equal to 2x plus 1. And v is the denominator, which for this question is 2x cubed plus 2x. Right, now what I like to do is write the u and the v separately and then put their derivatives down as well. So du dx, the derivative of 2x plus 1 is just 2. And dv dx, well, the derivative of 2x cubed is 6x squared. And the derivative of 2x is 2. And so now I kind of have the four parts that need to go into this formula. And I just find with the quotient rule, it's nicer to have them there separately to start with, rather than try to put them all in as you go. So now we can say, all right, well, dy dx, or the derivative of what we're asked to find, is equal to, okay, v, so I'm just going back to the formula here, v times du dx. So v, which is 2x cubed plus 2x, times du dx. And du dx was just 2, right? V times du dx. So I'm just going to put that 2 in front, minus u times dv dx. So u, which is 2x plus 1, times dv dx, which is 6x squared plus 2. And all of that is divided by v squared. And v in this question was 2x cubed plus 2x. So it's all that raised to the power of 2. Now, in terms of how to give your final answer, there can be some grey areas with this. Typically, if the question's just asking you to find a derivative and you've found a derivative, then that's kind of the answer, right? So this is dy dx. There's nothing really super obvious that we can kind of collect together or cancel out or anything like that. I mean, we can do some expanding and try to tidy this up, but typically speaking, you don't need to go any further than putting down the answer unless it's a really obvious simplification, right? Like unless you've got an x plus 2x somewhere, then you just add them together. So I'm going to argue that you can probably stop here. If you're checking your answer in the back of the book though, or if it's an exam question and it's multiple choice, chances are the answer mightn't be written like this. It might be, expanded and then terms collected together, and maybe there's some common factors you can work out and do some cancelling. So it's a bit of a tricky one, but for this example, just because we're practicing just applying the quotient rule, let's just leave our answer like that. But it is worth being mindful that if you were doing questions like this in a textbook, you might have to expand some brackets and collect some things together to get your answer to match what is in the back of the book. All right, let's have a look at example 25, another quotient rule question. We've got sine x over x squared plus 1 that we have to differentiate. Again, you don't have to do this, but I'm going to put u and v down separately to start off with, and then write du dx, and the derivative of sine x is cos x, and then dv dx, which is the derivative of x squared plus 1, which is 2x. Right, and then I'm going to write out the formula. Like I said, you can go straight to the formula. I just find it's sometimes I make mistakes when I do that, when I'm sort of doing things in my head as well as trying to get the formula, you know, how it should be. I just find this is a safer way of doing things. So the derivative here will equal, again, I'm going back to my formula here because even as a methods teacher for quite a few years, I often get the v's and du dx's the wrong way around when I do this. So v times du dx. So v, which is x squared plus 1, times du dx, which is cos x, minus u times dv dx, so sine x times 2x, and I'm going to put the 2x first, so 2x sine x, and all of that is divided by u squared, sorry, v squared, there you go, just to prove my point, I'm mucking up the quotient rule, v squared, which is x squared plus 1 all squared. Okay, again, you might be inclined to do some expanding and try to make your answer look prettier than that for some reason, but if the question is just getting you to find the derivative and you've found a derivative, then you're done, okay? Don't over engage with the question, don't lose marks that you've already got. Okay, let's have a look at an exam question. This one's from exam 1. And again, it's a quotient rule question. We've got f of x equals cos x over 2x plus 2, and we're asked to find the, or f dash of pi, right? So the derivative function when x is equal to pi. So there's going to be 2 steps here. We've got to get our derivative, and then we've got to sub in x equals pi to work out what that equals. So let's start from the start. We've got, yet again, I'm going to say, let's let u equal cos x and v equal 2x plus 2. Write the derivative separately. Derivative of cos x is negative sine x. Derivative of 2x plus 2 is just 2. And so bring that all together with the quotient rule. We get dy dx equals v times du dx, so 2x plus 2 times negative sine x minus u times dv dx, so cos x times 2, all over v squared, which is 2x plus 2 squared. Oh no, I've written dy dx, actually should have used the function notation, right? That's f dash of x, okay? And now f dash of pi, we just have to sub in x equals pi and work all this out. So it's going to be 2 pi plus 2 times negative sine of pi minus 2 cos of pi all over 2 pi plus 2 squared. Okay, so we're going to have to remember how to work out sine of pi and cos of pi. If you can't remember them off the top of your head, go to your unit circle. Remember that we read values of cos theta from the x-axis and sine theta from the y-axis. So if we're talking about pi, we're measuring from an angle of 0 around to an angle of pi. We're actually at this point on the unit circle. And at that point in the unit circle, we can see that the value of sine, so sine of our angle is 0. The y-coordinate here is 0. Okay, so sine of pi is going to be 0. And cos of pi, well, the value of cosine over here at this point is negative 1. The x-coordinate on the unit circle is negative 1. Right, so cos of pi equals negative 1. So f dash of pi, we can now simplify even further. We've got 2 pi plus 2 times 0. Well, that whole first term is just going to disappear because we're multiplying it by 0. Then we get minus 2 times negative 1. Okay, so minus 2 times negative 1, that's just going to give us a positive 2 on top. Now, again, arguably, you don't have to do anything here to do some simplifying, but, well, 2 pi plus 2 squared on the bottom, we could take out a factor of 2, kind of contradicting what I said before. You probably don't have to do this, but maybe it's worth seeing because in certain questions you'll have to give your answer in a certain form. So that'll give us 2 over, and if we square both bits inside the bracket here, we square the 2 and we square the bracket itself. And so we'd get 1 over 2 times pi plus 1 squared, right? I'd probably say that actually this answer, you probably have got the marks here, but this is just to be sure. And sometimes questions, as I said, will get you to write answers in a certain form. So it's not a bad thing to just see those extra couple of steps there. But I guess for the purposes of what we're trying to learn here, that's just another application of the quotient rule. You can see this working out method. You know, if you like it, keep doing it this way because it is a complicated formula. So sometimes it's nice to have all the parts separately and then put them together. Just a bit of a last thing on the quotient rule and one to watch out for. The quotient rule will work anytime you have one function divided by another, right? But just keep in mind that if you're being asked to differentiate something, you know, and it may not be this simple, but say you're asked to differentiate x to the power of 4 divided by x squared, right? Now that's a quotient, that's a division, but there's no way you'd use the quotient rule to differentiate that because you're just going to use your knowledge of index laws to say, well, that's the same as just x squared, and I'm just going to differentiate x squared using another rule. So if you see a fraction, don't automatically go to a quotient rule. Think about whether you can do some cancelling to make it a bit nicer. Sometimes, you know, there's a quicker way to do things. The quotient rule is a bit of a time-consuming rule. So just a word of warning, right? If there might be an easier way. For example, you know, some people see something like 1 over x cubed and they go, oh, it's a quotient, right? I'll use the quotient rule. But we know that that's just x to the power of -3, and so differentiating that is much easier if you just say multiply by the power, subtract 1 from the power, right? So just watch out and don't always assume anytime you see a fraction that it's definitely going to be a quotient rule question, because sometimes there's an easier way to get there. That's just an extra little note from me. Okay, as always, any questions, get in touch with your teacher, but good luck with your work on the quotient rule.